Hello everybody, the topic of this section is perpetual annuities. In this section, we will study an important and special type of annuity, perpetual annuity or perpetuity. There is no time limitation for the perpetuity. In other words, a perpetuity is a stream of cash flows that lasts forever. A classic example is the cancel bonds issued by the British government in the 19th century, which pays interest each year on the stated face value of the bonds but have no maturity date. Another example, and perhaps a more relevant one, is a share of preferred stock that pays a fixed cash dividend each period, usually every quarter year, and never matures. Because of the infinite lasting date, can we calculate the future value, FV, or present value of a perpetuity? Obviously, we cannot compute the FV of its cash flows because it is infinite. Nevertheless, it has a perfectly well-defined and determinable present value. For example, you put $1,000 into a bank account offering an interest rate of 10% per year. There is a perpetual stream of $100. Why? If you put in $1,000, then at the end of the first year, you would have 1,000 multiply 1 plus 10% to the first, which is $1,100. And you would take out $100, leaving $1,000 for the second year. Clearly, if the interest rate stayed at 10% per year, and you had a fountain of youth nearby, you could go on doing this forever. More generally, the formula for the present value of a level perpetuity is PV is equal to C over I, where C is the periodic payment and I is the interest rate expressed as a decimal fraction. Because as n increasing to infinite, the limitation of 1 plus I to the minus nth is 1. The present value of an ordinary annuity releases to A over I. So, the formula for the present value of a level perpetuity is the present value of an ordinary annuity with n increasing to infinite. In this formula for the present value of perpetuity, the periodic payment C is a constant, which means the cash flows are fixed. Well, if the cash flows grow at a constant rate, how to calculate its PV? Or in other words, how to evaluate the investment? For example, suppose that you are considering investing in a property for which you expect the first year's cash flow to be $1,000, and you expect it to grow by 4% each year in perpetuity. To evaluate such an investment, a growth perpetuity is defined as a series of periodic payments that grow at a proportionate rate and are received for an infinite amount of time. The formula for the present value of a growth perpetuity is the cash flow after the first period divided by the difference between the discount rate and the growth rate. That is, PV is equal to C1 over I minus G, where C1 is the first year's cash flow, I is the discount rate, and G is the growth rate. In formal example, we further suppose that the discount rate is 9%. By the formula, the present value of the property would be the first year's cash flow, $1,000, over the discount rate, 0.09, minus the growth rate, 0.04, is equal to $20,000. Therefore, if you can purchase the property for less than $20,000, it would be a worthwhile investment. Let's see an example about common stock. Suppose that you have the opportunity to buy stock in a company that is known to pay a cash dividend that grows by 3% every year. The next dividend will be $1 per share and is to be paid a year from now. If you require a 10% per year rate of return, how much should you be willing to pay for the stock? The answer is that you should be willing to pay the PV of the expected future cash flows discounted at 10% per year. The stream of expected future cash dividends is a growth perpetuity. So, using the formula for present value of a growth perpetuity, PV is equal to the next dividend, $1 over the discount rate, 0.1, minus the growth rate, 0.03, is $14.29. In summary, we have studied the concepts of perpetuity and a special one, growth perpetuity, and the calculations of their present values. That's all about this section. Bye.